Hello students, welcome back to my channel Explore Physics, Let's Explore. In the previous classes, I've solved few numerical problems based on series, parallel and combination of series and parallel connections. Today I'm going to explain you about the domestic electric circuits. Where do we use the series and parallel connections in the domestic circuits? So without further delay, let's start the class. You have seen the fairy lights or decorative lights in our houses. All these lights are operated by only one switch. You switch on the light, then the entire the decorative light or the fairy light starts glowing. But what if one bulb blows away or it's fused? Then all the bulbs will not function because they are in series connection. So what happens in series connection, that that the same amount of electric current flows through all the, in this case, all the bulbs here. So what happens if one bulb by any chance is fused or any other reason it's not working, then the entire light stops working. So we can't use the series connection here in our houses because there are so many appliances which we run in a domestic circuit or in a house. So if one appliance or if one equipment is not working, then the entire circuit, all the equipment stop functioning. So definitely we cannot be using the series connections there. Then it's clear, then we use the parallel connection in the domestic circuit. Because the biggest disadvantage of series connection is that one, it has to be operated by one switch, and two, you can't make out which that equipment is not working or functioning properly, and because of that the entire circuit and all the equipments will not function. So we cannot be using it definitely, and it's very difficult to locate or to find the faults that which equipment stopped working actually. So it's clear that for the all these decorative lines in all these cases we use series connection, but for all the other equipments in a house we use the parallel connection. There is one more. Why do we use in fairy lights and decorative lights the series connection? Because we cannot have different switches for different bulbs, of course. But here we can have for different equipments, like for instance in a room, if bulb is glowing, we have one switch for that. Bulb is operated by that. We have the switch for the fan or for a mixer, grinder, anything for that matter. So everything is connected in parallel, because if one of the equipment stops working, then all the equipments will not be affected by that. So that is one. So we'll be talking about this is clear now, that where do we use the series connection and where the parallel connection. So what are the disadvantages of series connection? We are going to talk about that. So disadvantages of series connection. There's so many disadvantages. We are going to discuss about that. So one, I've already made it clear, because it is operated by only one switch. So if one equipment goes wrong or doesn't work, so the current ceases to flow. The current will not flow to all the other equipment. This is the biggest disadvantage. Then the next disadvantage is that like current is flowing, the same current is flowing to all the apparatus, all the equipments, but different equipments will have different rating or different power. For instance, a 60 watt bulb will only use 60 watt, whereas a 100 watt fridge, or for that matter something is 1000 watt, you can say the heater, room heater and all, they want different current, different amount of current. Here the same current is flowing and the voltage is different, because in the domestic circuit we get the 220 volt current here in 220 volt AC in domestic houses. Current comes to us. So that in series connection I remains the same, but V differs, so or the voltage differs. So different voltage will be sent to all the equipments, which cannot help us. So this is also the biggest disadvantage. Now, why do we use the parallel connections? Now, what are the advantages of parallel connections? So what happens here, as I told you, different equipments will have different need of the current or different power. So what will happen here in parallel connection, we have same 220 volt line, or the voltage is 220 volt which is coming to our house is 220 volt AC. So that is one advantage. Two, the current varies, because what happens in parallel connection, V remains the same but I varies. So depending upon the power or the need of the equipment, the current will be different. Again, very big advantage. One more advantage, every equipment, like I've discussed before, every equipment will have, or all of them will have different switches for that. So in series we had only one switch, here we have different switches for different equipments, or according to the need we can use it. So this is the biggest advantage for parallel connection. Same voltage is coming here, the voltage is different in series. Here the voltage is the same, here the I same, but V remains, V is different, which we don't need it. Actually here voltage is the same, current varies because of the need of the equipment. Here only one switch solves the purpose. Here we can have different switches for different connections. So this is all about series and parallel connection. But the meter, electric meter, now we'll talk about it. We have to discuss it in detail later also. So electric meter is connected in series. In series we put the electric meter, because at the beginning, where from the source from where the electric current is coming, we have the big meters in our houses to measure the amount of electric power we are consuming per month. So that electric meter is always put in series. This is all about series and parallel connections, the advantages and disadvantages. Now I'll be talking about the power of electric current. What do you mean by power? You have read in the lower classes also in 9th standard and all, that power is equal to rate of doing the work. Remember, you've learned in the lower classes that power, the rate of doing the work is called power, which is equal to W by T. And here for electric power also, it's P is equal to W by T. I can write, we know that V is equal to W upon Q. Remember? Amount of work done to bring unit positive charge from one point to another is called the voltage or potential difference. V is equal to W by Q. Same thing I'm using, and from here I can write that W is equal to V into Q. Again, I know that this is voltage and here it is work done. So here, this is W is equal to V into Q, no problem. Now W I can write V into, if you remember that we said I is equal to Q by T. Remember, rate of doing moving of charge is called the electric current. So I can write, instead of Q here, I can write IT. So V is equal to W is equal to VIT. Same thing I'm going to use here, that P is equal to W by T, or instead of W I can write VIT divided by T, so is equal to VI. So P is equal to VI. Power is the product of voltage and the electric current. I'm repeating it again. Instead of W, we know that V is equal to W by Q through formula, and from here W is equal to V into Q. Again, we know the formula that I is equal to Q by T. From here I have taken, instead of Q I have written W is equal to V into, instead of Q I have written IT is equal to I into T, and W is equal to VIT. If I am going to substitute the value of the formula for W here, so W is equal to VIT by T, so P is equal to VI. Clear? So this power, electric power, is equal to V into I. I am writing it here. P is equal to VI. The unit of, so this is one formula for that. Unit of power is, its unit is watt, or denoted by capital W here. Now this P is equal to VI. If I'm going to write instead of V from Ohm's law, V is equal to IR. So I can write it IR into I. So my P will be equal to I square R. So I have one formula for P, VI. I can also write second formula, P is equal to I square R by I square R. I can also write it instead of P, VI, if I'm going to change I, so I can write it here. I'm going to put it like this so that's easier for you to understand. Here, I can also write that P is equal to VI. So instead of I can write it as V is equal to, I is equal to V by R. So is equal to V by R. So it is V square by R. So I can also write third formula for P, that P is equal to V square by R. Correct? So what did we do? P is equal to VI, the basic formula we have taken. Instead of V, we have written IR and the I, so it becomes I square R. Again, P is equal to VI if I am going to put the value of I, because V is equal to IR, so I is equal to V by R. So here, instead of I have written V by R, so it's become V square by R. So depending upon what all is given to us, in the numerical problem, we write the formula. So we have the one formula for P, that is W by T. That is actually this is the fourth formula actually, or the first formula. P is equal to W by T is one formula. P is equal to VI is one formula. P is equal to I square by R is one formula. P is equal to V square R by R, one formula. So these are different formulas which are going to use depending upon what is given in the numerical and what is not. Hope it's clear to you. We're going to talk about few more things now. So I'm writing here all the formula what we had deduced till now. 1, P is equal to W by T. Second, P is equal to VI. Third, P is equal to I square R. Fourth, P is equal to V square by R. So these four formula are there, which is very, very useful for solving the numerical problems. Please learn it. Easy for you to solve the numerical problems. Now we spoke that the SI unit of power is watt. So I can write from here P is equal to W by T, or its unit is watt. 1 watt is equal to, work is measured in joules, so 1 joule per 1 by 1 second. So what is the unit definition for power, or what is 1 watt? So when 1 joule of work is done for 1 second, the power consumed is said to be 1 watt. Work definition. When 1 joule of work, this is joule, don't confuse it by W here, this is watt, okay, and this is joules here. So when 1 joule of work is done till 1 second in an electric circuit, the power consumed is said to be 1 watt. If I'm giving you the energy definition, because work and energy are correlated, I will say that if 1 joule of energy is consumed in an electric circuit for 1 second, then the power is said to be 1 watt. So the question is define electric power. So you can use either one of this. Either you say that when 1 joule of work is done for 1 second, or you can say that 1 joule of energy is consumed for 1 second, then the power is said to be 1 watt. So both are correct. Alternate unit is joule per second. That is all about watt. Now this, like gram and kilogram, 1000 watt make 1 kilowatt. Okay, 1000 watt makes 1 kilowatt. This is about the electric power. Now let's talk about the energy side. Okay, so now if I'm talking about kilowatt hour, 1 kilowatt hour, this is small k children, okay, or you can write big H also here. So what is that? 1 kilowatt hour means 1000 watt. N2 hours means 3600. 60 into 60, that is 3600 second. And this is equal to 36 with 1, 2, 3, 4, 5 watt second. And what is watt second? That is joules. Watt second means joules, because you see this, we have in the beginning we said no, 1 watt is equal to 1 joule per 1 second. W is equal to P into T, that is watt into second. So that is what is joules. So 36 with 5, 0, 1, 2, 3, 4, 5 joules, or I can write it 36 into 10 to the power 5 joules. Easy to understand, most prevailing 3.6 into 10 to the power 6 joules. So 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joules. At times you will be told to, show the relation between kilowatt hour and joules. Now this kilowatt hour is the unit of commercial unit of electric energy. Kilowatt hour, I'll write it here. Kilowatt, this K is small, I'm telling you again, W is big. Kilowatt hour is unit, commercial unit commercial unit of electrical energy. Right? This is the commercial unit of electrical energy, kilowatt hour. 1 kilowatt hour we consider as one unit, and how many units or how many kilowatt hour is consumed by one domestic circuit or one household is built, and that's how the bill comes to our houses, electric bill comes to our houses. Okay, so this is all about the domestic circuit, about series and parallel connection, where do we use series and where do we use parallel connection in a household. Then we spoke about the power, then we spoke about the energy, and we spoke about the commercial unit of electric energy. Right? So kilowatt is the unit of power, but kilowatt hour is the unit of energy. And when I'm talking about P is equal to W by T, work done, rate of doing the work, that is power, and I'm saying that watt joules per second. This is, I'm talking about the units. Now when I'm talking about the energy, and you know that this is watt, okay, or I'll just write watt here, otherwise, you should not be confused by that. When I'm talking about the work done, W, this is energy, because work and energy are related or correlated rather. So instead of power, here I'm showing you how this is kilowatt, and power is in kilowatt and time is in hour. So that's why kilowatt hour, kWh also is said. Kilowatt hour is the unit of energy. This is work. This is work or energy. Energy or work, and this is kilowatt hour. So remember, kilowatt is the unit of power, but kilowatt hour is the unit of energy or work. All for the day. Stay safe, stay healthy, and a very big thank you all. Bye-bye.